Hey folks, how's it going? This is Rob coming to you with a overview of homework quiz number 7 for Math 130, Spring 2020. Okay, so in this video I'm going to go through the two main problems that we had, break down for you how do we solve them, and talk about any things that you might want to know. So the first problem is, find the area of a region completely enclosed by the graphs of x plus 2 and x squared minus 4. A graph has been provided, but graphing is not required. So in class, I said that I'm going to try to provide you with these graphs, and it's important that you think about how to use them. So I'm going to start with the graph of y equals x plus 2. Fortunately, that's going to be a line, so I'm going to kind of cheat here and use my line tool to help me. Okay, and then that, to be technical, I'll put arrows on the ends of them. So I'll redraw this line. I'm going to do the guise of making an extra dark line. Okay, and then I'm going to do my parabola, x squared minus 4. So I got minus 4, 0 minus 4. And then it's going to look something like this. Okay? And that's just based on what I know about to be true about parabolas. Now, not the best on the left, but the idea is we can see where they're enclosed. So this is the enclosed area. And again, pardon my parabola, it's not great. I'm kind of more focused on the enclosed area right now. So this area here is the area enclosed by the two graphs. And that's because it's locked in by the graphs. All right, if these are like fences. If you got a parabolic and a linear fence, if I'm in here, I'm locked in, right? This area here, down here, right? I'm bound, I'm stuck underneath it, but I'm not being locked in by this parabola fence. So I can roam the countryside all around here. I can roam the countryside all between here. But the thing is, I'm only really locked in between the two graphs. So you can see by looking that we really want to go from x is negative 2 to x is positive 3. Okay? The other way to know is that you take the equations and you set them equal to each other. Okay, so I start with this. I'm going to move my stuff over here to keep x squared positive. So x squared minus x minus 6 is 0. I then factor that as x plus 3 or x minus 3. X minus 3 times x plus 2 is 0. So x equals 3 or x equals negative 2. Two ways you can do it. And so what that tells me is this is my starting setup for my integral. Now, the reason that you might want to graph this is because you need to know which one's the bigger one. So this graph on the right shows me the bigger one is x plus 2 and the smaller one is x squared minus 4. Okay, because the order that you do these in is important for the integral there. Okay, so now I'm going to do negative 2 to 3, and let's simplify that. So negative x squared, okay, because 0x squared minus 1x squared, x minus 0, 2 minus negative 4. Okay, so this is what we want to differentiate, integrate rather. So this is negative x cubed over 3 plus x squared over 2 plus 6x from negative 2 to 3. So first we plug in 3, so it's negative 27 thirds plus 9 halves plus 18. Then we plug in negative 2, so we get, so that would be negative 8 thirds, so it's positive 8 thirds, because it's negative minus 8. Okay, then we get 4 halves, and then we get 12. So we have 27 thirds minus positive 8 thirds. That's negative 37 thirds. Then we have 9 halves minus 4 halves. Okay, that's 5 halves. Then we have 18 minus negative 12, and that's 30. Okay, so in other words, that's 70 sixths plus 15 sixths plus 180 sixths, if we're going to put them over the same denominator. So we essentially need to know negative 70 plus 15 plus 180, and that's 100 and 25/6. All right, so the idea here is step 1, find where the area is enclosed. So again, when you have these graphs, you might want to take a chance, especially if you're not someone who struggles with the algebraic version of it, to really graph it out. And if you take a second to do that and just make a table and graph some points, you're going to be able to find the intersection points of -2 and 3. Okay, because to do the area under the curve, you need 2 functions and you need the minimum and the maximum limit of integration. So to find those numbers, I'm either going to tell them to you or I'm going to give them enough information so you can find them yourself. In this case, when you see the words completely enclosed, that means that there's intersection points, and those intersection points here, -2 and 3, the x's of them, are going to be the lower and upper limits of integration. Okay, so I'm going to move on to the next one. So this is producer and consumer surplus. So the demand for a certain make of replacement cartridges for a water purifier is given by this, where P is the unit price in dollars and X is the quantity demanded each week, measured in units of 1,000. So this one was confusing because it says determine the unit price when the quantity supplied at P. So what I mean is not to say supply, I mean to technically say demanded. What I was getting at here is that I'm saying that there is a demand of 10,000 that is going to be supplied. But I've changed this for the future so that it's more clear. But what I'm getting at is that I'm giving you the P bar and there's a corresponding X bar. So I'm going to do this one first. Okay. So the quantity demanded is 10,000. That represents an X that's equal to 10 because X represents thousands of units. So 10,000 is represented by 10. So if X is 10, what is P? Well, for that, we just plug it in. So 10 squared times -0.01 plus 0.3 times 10 plus 8. So that would be 1, because it's -1 actually, because it's 100 times -0.01. -1 plus 3 plus 8, and that is 10. So that means the unit price, okay, for the water purifier when 10,000 are demanded per week is $10. Now we need to find the consumer surplus at that price. Okay, so I'm going to screenshot this real quick. I'll come down here and I'll repaste it. So here's my consumer surplus. So now I know I was given in the problem that the P bar is equal to, I don't know, and that X bar was equal to 10, and now I solve, and the P bar is 10. So what I'm going to do is I'm now going to come here. I'm going to grab this real quick. I'm going to do this. Shrink that. So what I'm going to do is integrate from 0 to 10 this function dx minus 10 times 10. Okay, so when I do that, I get plus from 0 to 10. We don't worry about 0 because they all have x's in them, times 100 minus 100. Okay, 10 times 10. So I plug in 10. This becomes minus 10 cubed. So that's 10 times 10, so that's 3 zeros. So I just gotta be careful here. So 10 cubed is 10 times 10 times 10, right? And that is 1,000. Then I multiply by 0.01 and I get 10. So I get, and then it's a negative. So it's -10 over 3 plus, okay, 10 squared is 100. So this would be 30 over 2 plus 80 minus 100. Okay, so what you get is you're going to get, let's see, this might end up even being a negative number. It's interesting. And that's possible. You might not have you might not always have a surplus. Okay, so And the reason is based on the certain things about demand, etc. So again, the idea is you integrated this 0.1001 thirds x cubed, 0.3 over 2x squared, right? Think about how that would cancel out. Integrated from 0 to 10. And remember, the 10 comes from plugging in 10 for x and figuring out the corresponding p, right? Because we got the 100 times this. It's negative 1 plus 3 plus 8. All right, and now let's convert this, I guess, onto sixths. So negative 26 plus 96 plus 486 minus 606. Okay, because we're just going to use our function here. Okay, so you can see this is a tall order, right? So I'll do negative 20 plus 90 plus 480 minus 600, and I get negative 56. And that's approximately negative 8.33 per unit. And I multiply that by 1,000, and I get a negative consumer surplus of 8,330. Remember, you're multiplying by 100, 1,000, I mean. So I got to actually go even more. 1, 2, 3. No, I got that right. So you're multiplying by 1,000 because each unit represents 1,000 things. So this is an issue for me because turns out that I'm actually going to end up having to pay more than I thought that I was going to pay. So this is actually a negative consumer surplus. Again, the negative number, not super important. I'm caring more about your ability here to correctly calculate P bar and X bar, to plug in and to integrate. For problem 2, the supplier of portable hair dryers will make X hundred units of hair dryers available in the market when the unit price is this. Determine the unit quantity supplied at a market price of $9 and then determine the producer surplus at that price. So this is a different situation. Now, instead of giving you X, I'm giving you P. So I'm saying P bar is 9. So what's the corresponding X bar? We do need to figure that out. So to get rid, I square both sides. So 81 equals 36 plus 1.8x. Okay, then I subtract 36 from both sides. I get 45 equals 18x. And then I divide 1.8x. So I'm going to do 45 minus 1.8, divided by 1.8. 45 divided by 1.8, I get 25 is equal to x. So the quantity supplied is 2,500 units. Okay, now I'm going to use that, now that that's my X bar, to go ahead and do the producer surplus. Okay, so first let me copy the producer surplus formula. Okay, and remember that's based on the supply function. So it's going to be a little bit more difficult to integrate, but that's okay. So let's start with the producer surplus. Now we know P bar is 9. So we know P bar is 9. X bar is 25. And then we'll also just quickly grab this little P function here. This is what we want to integrate. But let me just grab just the meat of it, really, just this part right here. So I've got this. I'm going to integrate this. Okay. From 0 to 25. And then here I have 9 times 25. Okay, minus that. So to start, 9 times 25, you can do that. It's 225. Minus, okay, now we have to do this. So to do this, let's let U equal 36 plus 1.8x. So du equals 1.8 dx. And so there's no 1.8 in here. So we're going to use du over 1.8 equals dx. So I can make the direct substitution. Now, 25. I'm going to plug 25 in. So I'm going to do 25 times 1.8 plus 36. And that's 81. So here I'll do my 1 over 1.8 because I have to take that 1.8 out as part of the substitution. So do 81 up here because I get 81 when I plug in 25. And then I'm going to plug in 0, and that will give me 36 because it's going to be 36 plus 0. Square root of u du. So that gives me 225 minus 1 over 1.8 times 2/3 u to the 3 halves from 36 to 81. Okay. Now, you would need a calculator to assist you with this. For sure. This is 225 minus 1 over 1.8 times 2/3 to the 81, or times 81 to the 3 halves, minus, and now this is the fundamental theorem of calculus. Okay? So 81 to the 3 halves. If you know about rational exponents, it's 81, like the square root of 81, the square root of 81, which is 9, and it's 9 to the power of 3. So if I do that on my calculator, I believe you get 729. So 225 minus 1 over 1.8, and now you have to do 2/3 of 729, and you get 486. Okay, over here, so 36, the square root of 36 is 6. 6 cubed is 216. And 2/3 of 216 is 144. Okay, so that's just me plugging in. And now I'm going to do 46 minus 144. And I get 342. So I get 225 minus 1 over 1.8 times 342. So when I do this times 1.8, I get 225 minus 190. And that's 35. So what that means is on every package of 100 units, I'm making $35. So now I take the 35 and I multiply it by 1,000, because the 35 means for every actual box I'm making 30. So imagine you had 1,000 per box, right? And each box you're making 35 on, essentially. So every unit. So I'm wondering for the whole thing, if I continue to do what's the unit, what's it going to be? So now I'm going to take this and I'm going to multiply it not by 1,000, actually by 100, because there's 100 things in the box. So I'm doing 135 per unit times 100 units in the box, and that's going to be 3,500 producer surplus. Okay? So the idea here is this. In order to do a producer surplus or a consumer surplus problem, you have to know the corresponding supply or demand function. You have to know the market price. You have to know the market quantity. Those information has to be given to you, or it has to be clear how to calculate it. So in this one, what I try to do is meet you halfway in terms of to say, hey, I'm going to give you one of these informations. You need to find the other. So in part 2, I gave you X bar. You had to find P bar. In part 3, I gave you P bar. You had to find X bar, right? So you had the function and you had enough information to calculate both pieces of information. And so once you know P bar, X bar, and the function, and again, those all have to be there, you plug them in, you do the integration, and you're good to go. So hopefully you found this to be helpful. We do have one more class before we take the final. So this is a really good time to make that strong last push and to really send those questions to me. I know that this is difficult, and it's challenging to be doing the virtual classes. But please feel free to send me questions anytime. You can reach me at robert.moray, MORAY, at umb.edu. Okay? Thanks for watching. Have a wonderful day, and I'll see you next time.